Today we discuss another application of Schrodinger wave equation for hydrogen atom or hydrogen-like atom. In this case, firstly we obtain Schrodinger wave equation for hydrogen atom in spherical polar coordinate system, and from that equation we separate three separate equations for radial, angular and phi part. Here we find potential energy of an electron for the hydrogen atom. For hydrogen atom, there is one electron and nucleus. The charge on electron is minus E and charge on the nucleus is Ze. If the electron is revolving around the nucleus in the particular orbit, that electron is at a distance r, then its potential energy is V of r is equal to Ze multiplied by minus E divided by 4 pi epsilon 0 r, where epsilon 0 is the permittivity of the free space and r is the distance of electron from the nucleus. For hydrogen, Z is 1, therefore its potential energy is minus E square divided by 4 pi epsilon 0 r. We have to find the Schrodinger steady state equation for hydrogen atom or hydrogen-like atom. Since in the hydrogen-like atom there is only one electron like helium plus and lithium plus plus ion. Here potential energy is independent on theta and phi. It only depends on r, and that potential energy is symmetric at all the points on the sphere of the orbit. Firstly, find what is Schrodinger steady state equation for the motion of electron in an hydrogen atom. Potential energy is independent on time, hence we use steady state equation. That equation is the Schrodinger time independent wave equation minus h cross square by 2m del square psi of r plus v of r psi of r equal to E psi of r, where del square is the Laplacian operator. That Laplacian operator we express in spherical polar coordinate system. So the function of electron, wave function for the electron is depends on r theta phi. Therefore, the psi of r will replace r theta phi and it is a wave function for the hydrogen atom. Del square operator term we write in spherical polar coordinate system and it is del square equal to 1 upon r square dev of dev r into r square dev of dev r plus 1 by r square sine theta sin theta into dev of dev theta sin theta dev of dev theta plus 1 upon r square sin square theta dev square by dev phi square. This del square term we have to substitute in the equation number 2 and psi of r is replaced by psi r theta phi. That equation we solve here. Minus h cross square by 2m into, this is the whole bracketed term is the value of del square. We keep as it is 1 upon r square dev of dev r into r square dev of dev r plus 1 upon r square sin theta dev of dev theta into sin theta dev of dev theta plus 1 upon r square sin square theta dev square by dev phi square into psi r theta phi plus v of r psi r theta phi equal to E psi r theta phi. Here we simplify this equation by multiplying on both sides by minus 2m by h cross square. Therefore, for first term, minus 2m by h cross square, this term cancel with minus h cross square by 2m. Second term is multiplied by minus 2m by h cross square, and on the other side we also multiplied by minus 2m by h cross square. Equation is 1 upon r square d above d r into r square d above d r plus 1 upon r square sin theta into d above d theta sin theta into d above d theta plus 1 upon r square sin square theta into d square by d phi square into psi r theta phi minus 2m by h cross square v of r psi r theta phi equal to minus 2m by h cross square e psi r theta phi. Now this one side term we take other side and that equation equating to 0 by simplifying 1 upon r square d above d r into r square d above d r plus 1 upon r square sin theta into d above d theta of sin theta d above d theta plus 1 upon r square sin square theta into d square by d phi square into psi r theta phi plus 2m by h cross square take common for v of r and e. We write the equation into bracket e minus v of r psi r theta phi equal to 0, where v of r is the potential energy of an electron in hydrogen atom and its value we find earlier. It is minus e square divided by 4 pi epsilon 0 r. That value we substitute here and simplify the equation. 1 upon r square d above d r into r square d above d r plus 1 upon r square sin theta into d above d theta sin theta d above d theta plus 1 upon r square sin square theta into d square by d phi square into psi r theta phi plus 2m by h cross square into bracket e plus e square divided by 4 pi epsilon 0 r into psi r theta phi. This equation is known as Schrodinger steady state wave equation for hydrogen atom or hydrogen-like atom in spherical polar coordinate system. Using that equation, we separate three independent terms like r radial part, theta part and phi part from the equation A. For that, we use separation of variable method, where psi r theta phi, we separate three independent terms. First term only depends on r, therefore it is function of r, theta function of theta only, and phi is function of phi. Substitute this term in the equation A. Here, if each term is independent, we write equation A with perfect differentiation since each term is only one variable. Therefore, 1 upon r square d by dr of r square dr by dr into theta phi. Since the first term in the equation A differentiate only with respect to r by keeping theta phi constant, and we get this first term. For second term, we differentiate with respect to theta, so r and phi kept constant, and simplified term is 1 upon r square sin theta into d by d theta of sin theta d theta by theta into r phi. Third term we differentiate with respect to phi and keep r theta constant, so the term becomes 1 upon r square sin square theta into d2 phi by d phi square into theta r plus 2m by h cross square into e plus small e square divided by 4 pi epsilon 0 r into r theta phi equal to 0. This equation again we simplify by multiplying r square sin square theta divided by r theta phi. Therefore, each term becomes in that equation, if we multiply r square sin square theta divided by r theta phi for the first term, the simplified term is Here theta phi cancel, 1 upon r is remaining. Here r square cancel and sin square theta is term right here. Sin square theta by r into d by dr of r square dr by dr plus for second term, if we multiply r square sin square theta divided by r theta phi, r phi cancel as well as r square cancel. Numerator remain term is sin theta divided by theta into d by d theta of sin theta d theta by d theta plus for third term, here theta r cancel, only remaining term is phi, r square sin square theta is also cancel and term becomes 1 upon pi d2 phi by d phi square plus here r theta phi only cancel and multiplied term is r square sin square theta. Therefore, the last term is 2m by h cross square r square sin square theta into bracket e plus small e square divided by 4 pi epsilon 0 r equal to 0. In that equation, 1 upon pi into d2 pi by d phi square only depends on phi, but the first term is the combination of r theta. Last term is also combination of r theta. Only the one term is function of theta only, but other combination terms are here. Hence, only one term is here, 1 upon pi d2 pi by d phi square. That term we separate from that equation and we rewrite the equation. 1 upon pi d2 pi by d phi square equal to, if we keep all terms on the one side, we take minus sign and into bracket sin square theta by r into d by dr into r square dr by dr plus sin theta by theta into d theta by d of d theta of sin theta d theta by theta plus 2m by h cross square into r square sin square theta into e plus small e square divided by 4 pi epsilon 0 r. If phi term balances with all other terms on the one side, hence each side must be equal to some constant, and that constant we choose ml minus ml square. Now what is ml? ml is one of the magnetic orbital quantum number. That from that equation we write two separate equations. One is 1 upon pi d2 pi by d phi square equal to minus ml square, and all other terms on the one side also equal to minus ml square. Hence, we write the two separate equations. That equation 6 is 1 upon pi d2 pi by d phi square equal to minus ml square and minus whole bracket term sin square theta by r into d by dr of r square dr by dr plus sin theta by theta d by d theta of sin theta d theta by theta plus 2m by h cross square r square sin square theta into bracket e plus e square divided by 4 pi epsilon 0 r equal to minus ml square. Hence, we simplify the equation 6 and equation 7. Here from equation 6, we get phi part of the equation. So, we call this is the equation small a d2 pi by d phi square plus m l square phi equal to 0. This equation is known as phi part of the equation. Now the two independent terms are remaining, r and theta. That two terms we also separate here by using the equation 7. Equation 7, if we take earlier minus sign is on both sides, it get cancelled and we write sin square theta by r into d by dr of r square dr by r plus dr by dr plus sin theta by theta into d by d theta of sin theta d theta by theta plus 2m by h cross square into r square sin square theta into bracket e plus E square divided by 4 pi epsilon 0 R equal to ml square. Here equation 7 we simplify by dividing on both sides by sine square theta. Therefore, the first term becomes 1 upon r into d by dr of r square into dr by dr. Sine square theta for first term gets cancelled. For second term, here if we divide sine square theta, 1 sine theta cancel and remaining term is 1 upon theta into sine theta into d by d theta of sine theta d theta by theta plus 2m by h cross square into r square. Sine square theta we divide here, therefore both term cancel and only remaining term is r square into bracket e plus small e square divided by 4 pi epsilon 0 r. This ml square is on one side. If we take on the other side, it becomes minus and divide by sine square theta. Therefore, the term is ml square divided by sine square theta equal to 0. In that case, first term only depends on r and third term also only depends on r. Hence, first and the third term we combine together, same as second and fourth term only depends on theta. Hence, we equate this term separately and both equations equal to some constant, and that constant we choose lambda or lambda equal to L into L plus 1, where L is the orbital quantum number. Hence, first and third term we keep on one side, 1 upon r d by dr of into bracket r square dr by dr plus 2m by h cross square into r square into bracket e plus small e square divided by 4 pi epsilon 0 into r. This is one side, and second and fourth term we keep on the other side. This becomes minus into bracket 1 upon theta into sine theta into d by d theta of sine theta d theta by theta minus ml square divided by sine square theta. If both terms equating, it must be equal to some constant, and it is L into L plus 1. Hence, from equation 9, we again write the two equations, each equal to L into L plus 1. Hence, we write the equation 10 for 1 upon r square into d by dr of r square dr by dr plus 2m by h cross square r square into bracket e plus e square divided by 4 pi epsilon 0 r equal to lambda. That equation only depends on r equal to lambda or L into L plus 1. This is the equation number 10. Similarly, equation 11, other side, here is minus sign, we take on the other side, it becomes 1 upon theta into sine theta into d by d theta of sine theta d theta by theta minus ml square divided by sine square theta equal to minus lambda. We solve these two equations separately in the next lecture. Before that, we write what is the equation 10 and 11. From equation 10, we multiplied by r, capital R, on both sides. The equation becomes d by dr of r square into dr by dr plus 2m by h cross square r square into bracket e plus e square divided by 4 pi epsilon 0 r, bracketed term multiplied by r equal to lambda r. Here we again divide by r square. Since for second term multiplied term is r square, therefore we divide and simplify. It becomes 1 upon r square d by dr of r square dr by dr plus this r square cancel 2m by h cross square into bracket E plus E square divided by 4 pi epsilon 0 R. This lambda is on one side, we take on this other side, and its sign is minus, divided by R square. Common is R equal to 0. Equation B is known as radial part of the equation. And from the equation 11, we find theta part. So the equation is 1 upon theta into sine theta into d by d theta of sine theta d theta by d theta minus ml square divided by sine square theta plus lambda equal to 0. If we multiply theta to this equation becomes 1 upon sine theta d by d theta of sine theta into d theta by d theta plus lambda minus ml square divided by sine square theta multiplied by theta, and the equation C is known as phi part of the equation. Hence equation B is the radial part and equation C is the theta part for the Schrodinger equation for hydrogen atom. In the next lecture, we solve how to find the solution of the radial part of the Schrodinger equation.